No one knows just how or when the first railroad was built. We do know that 400 years ago, men were moving coal from mines using small trucks with flanged wheels running on timber rails. Although not officially called a railroad, this method of transporting material was probably the beginning of railroads as we know them today. The little trains went from the surface down into the mine and back again. Several hundred years later, in the U.S., short railroads were built for local transportation. These railroads used cars built of wood drawn over tracks by horses. As these railroads' popularity grew, more and more people and cargo began moving by rail. Along with this increased popularity came requests to travel to different destinations. This was a lot different than traveling from one end of the line and back again. It required a method of switching the cars from one track to another. In 1869, George Westinghouse came up with a device that enabled a train to move from one track to another. We don't know why, but this remarkable invention was called a frog. Frogs are still used in today's modern railway systems, although improvements have been made with the passage of time. Before 1980, Norfolk Southern made its spring frogs at the Charlotte Roadway Shop. When space was needed for expansion in Charlotte, the frog shop was moved to its current location in Birmingham. At that time, all of the frog's rail components were machined using planers. This method required the rail to be attached to a planer table that passed repeatedly under a cutting tool. A small amount of material was removed from the rail with each pass. There was a considerable amount of idle time as the table retracted during each cycle. Using this method to manufacture a frog required 16 separate setups and took approximately 30 hours to machine the parts. Then in 1988, Norfolk Southern began modernizing the frog shop, and we took a giant leap into the future. Utilizing the most modern technology available today, the Birmingham Frog Shop manufactures spring frogs. The primary rail components of a spring frog are the spring rail, the point rail, the splice rail, and the wing rail. The rails are machined, then bolted together and attached to steel plates. Stock rail and guard rail, as well as other non-rail parts, are either refurbished or manufactured here too. Rail arriving at the Birmingham Frog Shop is placed on a glide outside the shop by a mobile hydraulic crane. The glide conveys it inside the shop, where it comes to rest against a preset adjustable stop at the carbide saw. This is the first of several stations on the milling line. The saw has 72 carbide teeth and can cut a rail to length in 1 minute. An operator controls the saw with the control panel. Depending upon which parts are being made, rail is cut in lengths from 9 feet up to 39 feet. Parts requiring angle cuts travel onto a conventional metal cutting bandsaw. Here, varying angle cuts up to 45 degrees are made. Next, the rail moves on to a CNC, computer numerical control drilling machine, which knows how many holes are needed and where to drill them based on data that is entered by the operator. Depending on the part being made, it will drill as few as 2 and as many as 20 holes in a rail. In addition to drilling, it automatically deburrs and chamfers each hole. Once drilling is complete, the operator enters data into the material handling system, identifying the part and where to store it. Because parts are made in lots and the cutting and drilling processes are faster than other process steps, the cut rails are placed in temporary staging areas by the automated materials handling system. All of the rails are deburred by hand. Deburring is an important process for several reasons. It allows cleaner joints, it helps prevent stress fractures, and it makes handling the parts safer since sharp edges are removed. 4 different size frogs are manufactured here in Birmingham. The size is determined by the poundage of the rail used: 100, 115, 132 and 136-pound rails are used, depending upon the type of track in which the frog will be installed. If the part being made requires that the rail be bent, the operator enters data into the materials handling system, which brings the rail to the bending station, where it enters a rail heater. Once the proper temperature is reached, the bend is made on the hydraulic bending station. The materials handling system then places the rail in the proper holding area to await its turn at the milling machine. The milling machine has two transport tables that hold the rail during the milling process. Each table can operate independent of the other. However, if a long rail is being machined, a bridge is inserted between the two to make one long continuous transport table. The transport tables have twin mounting decks, one on each side, so two rails can be transported simultaneously. An operator begins the actual milling process using a control panel to tell the materials handling system to place a rail alongside one of the two transport tables. After the rail is placed onto the transport table, the operator uses a fixturing pendant to start the clamping sequence. A product code for the part being made is dialed into the pendant. This code tells the computer controlling the clamping process which combination of clamps to use. For example, when making a spring rail, some of the milling is done on top of the rail, so some of the top clamps are not used because they would be in the way. Only base clamps are used in the area where the top of the rail is to be machined. The clamps are interchangeable and can be removed by releasing a locking pin. Centering the rail on the table is the first step in the clamping sequence. An indicator light on the pendant confirms when each step in the clamping sequence has been completed. Once the rail is centered, the ball clamps and base clamps are secured. The final step is securing the work supports, which dampen any vibration that might occur during milling. The versatility of the milling machine currently allows us to manufacture these parts in both left and right-hand configuration. Wing and spring rails only require machining on one side, while point and splice rails require milling on both sides of the rail. Parts requiring milling on both sides are loaded on one side of the transport table, machined, then loaded on the other side of the table to machine the opposite side of the rail. An important feature that was written into the machine specifications by Norfolk Southern's engineers during the design process is pivoting clamping stations. This allows the transport tables to be configured for clamping curved rails and makes the machine much more versatile than one with stationary clamping. The operator uses a hydraulic valve located below the table to move the station into position. Precise settings are achieved by using gauging blocks. The brain of the milling machine is a computer which contains various programs for making each part. A control panel tells the operator the status of the machine, the milling tools, and the part being made. It also allows the operator to enter information and instructions. When the operator starts the computer program, it performs a self-check of the machine before it switches to the CNC program. Once the CNC program begins, the machine loads the proper cutting tool into the spindle unit, moves the head assembly into place, and at the same time advances the transport table containing the rail, and milling begins. Here a stock rail is being machined on the top right side. Once the cut is complete, the machine repositions the rail and moves the spindle unit adjacent to a chain-driven tool carousel that positions itself so a robot arm can remove and store the cutting tool and install the proper drill. All of this happens automatically because the necessary information is contained in the CNC program. With the proper drill installed, the machine drills the appropriate holes in the rail. Coolant is sprayed on the rail during drilling to prevent overheating. When drilling is complete, the machine goes through another automatic tool change sequence and chamfering completes the part. Other spring frog parts are either refurbished or manufactured in other areas of the shop. Old frogs are disassembled. The rail and everything but the cast parts are sold as high-grade scrap metal. The cast parts, heel risers, filler blocks, spring housings, wedges, core washers, and reinforcement bars are kept. Next, the heel risers are gouged. Heel risers and filler blocks are built up at welding stations. Then they are planed to fit the contours of the rail. Almost all parts that require bending are forged anew. These include hold-downs, horns, headlocks, and rail clips. Material stock is heated in the forging furnace, then placed in dies that are rammed together to form the various forged parts. Base plates are made on a CNC burning table, which cuts the plate out of material stock. The cutout portions are used to make hold-downs and stops. The base plate is then placed on a CNC punching machine, where holes are punched in a prescribed pattern. The pattern can be changed by changing the program using the computer located at the control console. The first step in assembling a spring frog takes place in sub-assembly 1 area. Here, the point rail and splice rail are placed on a table and riveted together to form a point assembly. The point assembly is transferred to a second table. Then a wedge-shaped heel riser is inserted between the 2 rails to ensure the proper angle of the rails is maintained. And the wing rail is bolted on, along with the filler block. The blacksmith uses a straight edge and gauge to ensure all of the parts align properly through the point assembly and wing rail. In sub-assembly 2, reinforcement bars and horns are attached to the spring rail. Then the spring rail is attached and the entire assembly is tack welded to the base plate. Spring housings that cause the rail to snap shut after the train's wheels pass through the frog are mounted to both sides of the assembly. And the toe block, which serves as a joint when the frog is installed, is attached. Final assembly takes place in the frog welding area. Here the assembly is mounted on a rotating table. The table is rotated so the spring rail can be moved to the open position. A gauge is inserted that causes the spring rail to move to its maximum position. The base plate is prepared for hold-downs and stops, which are permanently installed by welding on both the top and bottom side of the plate. The completed frog is inspected by a supervisor and stamped with a unique serial number before it leaves the shop. The Birmingham Frog Shop is one of the most state-of-the-art manufacturing facilities of its type anywhere. The advanced technology of the automated milling line allows us the versatility to manufacture a wide variety of parts with very quick changeover times between products. The products that can be made here are basically limited only by one's imagination. The Frog Shop's highly skilled personnel now produce more parts, more accurately, in less time, and for less cost than was ever before possible. A giant leap into the future at the Birmingham Frog Shop is helping to keep Norfolk Southern the safest, most customer-focused, and successful transportation company in the world.